Okay, this last slope video is on real world slope. So some things you need to remember when we're talking about real world slope is remember y's are over x's when we're talking about things. And that'll make more sense, but just remember, because when you calculate your slope, remember you did y1 minus y2 over x1 minus x2. So when we talk about slope, it's the y topic over the x topic. So the graph shows the hours worked and total pay for Paul's part-time job. What does the slope of the graph represent? So the y over the x. So the pay, because that's what our y is, over our x, which is hours. Okay, so your choices are hourly pay, days worked, hours worked, or money earned. So if you look at the y over the x, it's pay per hour or hourly pay. So it's A. Okay, remember when they're on their side, it's still x and then y. Okay, so the table shows how much Donna charges for doing yard work. She charges a fixed fee plus an hourly rate. What is Donna's hourly rate? So how much does she charge per hour? Okay, so you're just going to do y1 minus y2 over x1 minus x2. Okay, so I'm going to do 17 minus 11, but if you're putting it in your calculator, you're going to get the same thing. Okay, since I decided to do 17 minus 11, then I have to do 2 minus 1. You could have done 11 minus 17 over 1 minus 2. So 17 minus 11 will be 6. Over 2 minus 1 is 1. So $6 per hour is her hourly rate. Okay, you could also look at the table. These are increasing by 1. So what is the change is what you would ask yourself. The slope means rate of change. How is it changing? Per hour, per whatever your units are in. But so slope also means rate of change. Okay, the table shows delivery service charges according to the number of miles traveled to make the delivery. We have the miles traveled and the charge. What does the slope of the relationship represent? Before you even look at the answers, remember in our table, this is x, this is y. So your y is charge. Since you write charge, oh my gosh, this pen is just not cooperating. It's supposed to say charge over miles traveled. I'm just going to write miles. It's not working too well for me here today. Okay, so our rate of change or our slope is the charge per miles. So now let's look at our options. The ratio of the amount charged to miles traveled, the ratio of the miles traveled to the amount charged, the ratio of the change in miles traveled to the change in the amount charged, the ratio of the change in the amount charged to the change in the miles traveled. I'm going to double check so I don't tell you the wrong answer. Okay. The ratio of the change in the amount charged over the change in miles traveled is your ratio, is your slope. So it's charge over miles. So that really got you down to A or D because we knew it was charge over miles. But the key here, it's the ratio of the change here and the change here. So that's why your answer is D. Todd deposited $200 in his account. The graph shows the money in his account will increase over the next 10 years. What does the y-intercept of the graph represent? Remember in y equals mx plus b, B is your y-intercept. That's where you begin. After you graph that, then you use your slope to move from there. So your y-intercept is where you begin. So the y-intercept is here at 200. What did we hear about 200? That's the amount Todd deposited in his account. So that would be D, the original amount deposited. Remember, B is where you start and M is how you move. So the B is going to be your initial input, and then this is going to be how you move from there. An oil tank contains 100 gallons of oil when Paul starts to fill it. Paul pumps oil at a rate of 20 gallons per minute. The graph shows the the number of minutes Paul pumps oil into the tank and the amount of oil in the gallons of the tank. Based on the graph, which statement is true? Okay, the line of PQ is 20. The slope of PQ is 100. The value of y at point P is 20, or the value of y at point Q is 100. So we know it started with 100 gallons. So the value of P is 100 because it started, remember y equals mx plus b, our y-intercept is 100 because this is the amount of oil. This is the number of minutes. So make sure you're looking at your y and x axes. Okay, so this can't be true. And so then we know that Q can't be true because this isn't 100 up here. Really, this is 100 down here. So really now we're looking at the slope. Okay. And so what is it increasing by? He's doing 20 gallons per minute. And so is the slope of the line 20 or is the slope of the line 100? So in 5 minutes, he's actually pumped how much? If he's doing 20 gallons per minute, it would be 20, 40, 60, 80, 100 right here. Okay, and then he goes another 5 minutes, 20, 40, 60, 80, 100. So the slope is 100. It's changing by 100 gallons per 5 minutes. Okay, this one's a little tricky. You really had to make sure you look at your axes. And then look, these aren't labeled 1, 2. You know, if this was labeled 1, then the slope of 20 would be correct. However, it's labeled 5. So over 5 minutes, doing 20 gallons per minute, that's going to be 100 gallons. So the slope is 100. Okay, so really just pay attention to what they're asking and how things are labeled. Bookstore retail sales at the end of 1996 were 500,000. By the end of the 2000, the retail sales had increased to 600,000. What was the average rate of change? Okay, so you have your Y1, your X1, let's erase that. Let's write our actual points here. So in 1996, we had 500,000. Oh my gosh, I apologize. This is driving me crazy that it's so sloppy. Okay. And in 2000, a better writing program. Okay, it was 600,000. Okay, so there's your 2 points that you pull from your data. Okay, X1, Y1, X2, Y2. So you're going to take 600,000 minus 500,000 divided by, well, I guess you can go either way. I guess I'm trying to make it positive, but you're going to pop it in your calculator. So you can do 500,000 minus 600,000 over 1996 minus 2,000. Or you can do 600,000 minus 500,000 over 2,000 minus 1996. Either way, you're going to get the same answer. So when you pop that in your calculator, you should get H. 25,000 was the rate of change per year. So every year, they increased their sales by $25,000. And that was the last one. Okay, so now you should be thoroughly good on slope. We've gone over parallel, perpendicular, horizontal, vertical, how to put them in your calculator, y1 minus y2 over x1 minus x2, and to understand when you're looking at tables, y over x. Your y value over your x value is going to tell you your real world situation.